Hi everyone! Which firmware are you using for your printer? When was the last time you updated it? Are you sure you're using your printer's hardware to its full potential? Today I want to talk about one of the most advanced, fast-growing and feature-rich open-source firmware. If you never really thought about firmware differences, you probably heard about Klipper. There are many step-by-step guides online for installing firmware on different devices. Initially, I planned to make a few similar guides for different installation methods, but I realized that I have so much interesting information to share that it wouldn't fit in just one or even two videos. So I decided to start a new video series about Klipper. With this series, I don't just want to show you specific installation steps. I want to help you understand how everything works. Personally, I don't like just following instructions and copying commands from one window to another. I need to understand what I'm doing and why. That's why these videos will contain a lot of information that may not seem directly related at first, but it will help you to see bigger picture. So, if you don't just want to install something but actually understand what, where and why, this series is for you. This part will be mostly informational. Today I'll talk about the most popular open source firmware available right now, their main strengths, weaknesses and how they compare to Klipper. I'll also explain what hardware you can use to install Klipper. The actual installation, setup and configuration will be covered in the next videos, which I'll try to release as soon as possible. So, the three most popular firmware today are the good old Marlin, the also old but not so good RepRap firmware and of course Klipper. I am not going to talk about closed firmware here. You cannot install and configure them the way you want. They are locked to specific hardware. There are some exceptions like large boards, which are closed source but still versatile. However, most of what I hear about them lately is people trying to install Klipper instead of original closed firmware. Open source firmware is great because it's developed with help of a large community and gives you huge possibilities for customization, modifications and fine-tuning your device. First firmware, Marlin, already a classic. The first versions appeared back in 2011. It was a combination of GRBL, which is still used for CNC machines today, and Sprinter, an even older firmware for 3D printers. Marlin quickly gained popularity and started to grow, outcompeting almost all other firmware at the time. Some old firmware like Repeater or Smoothyware still exist and even receive updates, but I haven't heard of anyone actually building printers with them in a long time. The first versions of Marlin ran on 8-bit Atmega microcontrollers and were essentially a huge Arduino sketch. This sketch had to be configured for a specific printer, compiled, and then uploaded to the printer board using a USB cable or a programmer. Some parameters could later be changed using G-code commands, but all the main printer settings had to be adjusted in the source code, which is not very convenient. Since 2018, Marlin has supported 30-bit microcontrollers. Today it includes almost all modern features for improving print quality and speed, such as linear advance and even some kind of input shaping. However, all these features are constrained by the limited processing power of the microcontrollers. Marlin is still difficult to configure. There are few configurators and build plugins, but it doesn't help much. It still doesn't fully support touchscreens. All touchscreens displays for Marlin have their own microcontroller and firmware, interacting with the Marlin as a separate device. Some of these screens even caused print problems in the past. There are still no built-in web interface. You can use Octoprint or similar programs running on the external host device, but these are just external tools for easier interaction with the printer. All G-code processing and stepper motor control are still handled entirely by the printer's microcontroller. Some boards and printers can receive G-code files for Marlin over Wi-Fi without a host. They achieve this by including a Wi-Fi module with the additional microcontroller, but these solutions are usually slow and not really functional. Despite all these limitations, Marlin supports a huge number of 3D printer boards and models and remains the most widely used firmware in the world. The second on the list is RepRap Firmware. It was first released and actively developed in 2013. And it was one of the first firmware to support 32-bit microcontrollers. Until Marlin introduced 32-bit support, RepRap was the leading choice in this segment, even though it supported only a very limited number of boards, specifically duet boards. With the release of Marlin 2.0 and Klipper, RepRap firmware almost completely disappeared from DIY community, but it's still widely used in professional and high-end 3D printers, due to its stability, support for expansion boards, a user-friendly web interface called Duet Web Control, and extensive customization options for different printer configurations. Unlike Marlin, RepRap firmware allows you to change printer settings without recompiling the firmware using the special G-code commands. In fact, all configurations in the RepRap firmware are stored in the plain text G-code files, where each G-code command defines a specific parameter. RepRap, like Marlin, can run standalone, meaning the printer board handles all tasks by itself. However, because it is designed for more powerful microcontrollers, it can also run the web interface and control a touchscreen display directly. RepRap firmware can also be partially installed on the single-board computers. In this setup, the computer handles the web interface, enables webcam control, and manages additional devices. However, all motion calculations, just like in Marlin, are still performed by the printer's microcontroller. There is the version of RepRap firmware that can be installed on some standard printer boards, but it is a parallel version that is rarely updated and quite difficult to install. Some companies produce duet board clones that can run the original firmware, but they are not very common. In the industrial sector, RepRap firmware remains one of the leading solutions. However, for the average user, usually it's not the most practical option. And now, the star of the show, Klipper. The first public versions of Klipper were released by Kevin O'Connor in 2016. The key difference between Klipper and all other firmwares is that it operates using not only 3D printer's control board. Instead, it works in tandem with a more powerful device, such as a Raspberry Pi. The idea behind Klipper is that all major motion calculations and processing of G-code commands are handled not by a weak microcontroller, but by a much more powerful ARM processor. Since Raspberry Pi itself cannot directly control motors and sensors due to its CPU architecture and operating system, it simply sends pre-processed low-level commands to the printer's microcontroller. These commands require minimal memory and processing power. As a result, even budget printers gain access to advanced web interface and additional resources, allowing for more complex behavior and increased printing speeds. For example, Pressure Advance, which is similar to Marlin's Linear Advance, compensates for pressure changes in the hot end during turns. Thanks to Klipper's high processing speed and better microcontroller response, it works much more smoothly and doesn't require major speed reduction. Another feature, input shaping or resonance compensation, has completely changed how 3D printers are designed now. It suppresses ringing artifacts caused by vibrations during rapid movements. With this feature, printers suddenly became capable of printing several times faster while maintaining the same quality. This method of resonance compensation isn't new, but in 3D printing it was first implemented in Klipper. Klipper supports touchscreen displays with the user-friendly interface called Klipper Screen. At the same time, it still allowed the use of standard LCDs. It supports many different kinematics, additional devices, drivers, and sensors. Several web interfaces are available. There are also many community-driven forks of the project where users modify the firmware and add new features. Klipper is the constantly evolving system that continues to grow and improve. So, Klipper is built on a host microcontroller system. The host side software is written in Python, and without going into details, it's essentially an application, or more accurately, a package for Linux. The host handles all calculations, command processing, application of configured features, the web interface, camera function, and more. All configuration files are also stored on the host, meaning any printer settings can be changed without reflashing. Just a simple restart is enough. Similar to Duet expansion boards, the single Klipper host can work with the multiple microcontrollers. Even if axis motors are controlled by one board, the extruder by another, and the heaters by third, The hosts synchronize everything so that the system functions as a one device. This is especially useful if your board doesn't have enough ports for some complex kinematic system. Just add another board and you get extra ports for motors, heaters, end stops, fans, and more. Additionally, if the host device is powerful enough, it can run multiple Klipper instances at once, allowing it to control multiple printers at the same time. This is advantages of multitasking in Linux system. The host can run on different devices. The most common and universal option is the Raspberry Pi. This is the easiest choice since most new hardware, firmware features and additional packages are tested and optimized for Raspberry Pi. In most cases, when setting up Klipper on the original Raspberry Pi, following the official instructions is enough. There are several types of Raspberry Pi used for Klipper, with a few generations. Instead of listing them all, the general rule is that any Raspberry Pi released after 2018, or at least Pi 3B Plus, will work. The only exception is the Raspberry Pi Pico, which is not a single-board computer but a microcontroller. Minimum RAM requirement for Klipper is 256 MB. However, if you start adding extra devices, cameras, features and macros, the web interface or even the printer itself may begin to lag. That's why I recommend at least 520 MB, but ideally 1 GB of RAM or more. The most convenient option is the full-size Raspberry Pi. It has the most powerful processor, the most RAM, full-sized ports, plenty of GPIO pins for additional hardware, and the best documentation. Its only drawback is its size. It's the largest of all the options. The second option is the Raspberry Pi Zero. Its size is the main advantage, making it the smallest option available. But that's where the benefits ends. It had the slower processor, less RAM, less ports, all of which are smaller than standard size. It has GPIO pins, but usually it requires soldering. This is the good choice for those who don't plan to add too many extras to their printer and ready to solder something if needed. The last suitable option is not exactly a standalone device. It is the Raspberry Pi Compute Module. In terms of hardware, it's a fully sized Raspberry Pi, but it doesn't have any standard ports. Instead, it has a connector on the bottom for installation onto specialized expansion boards, with additional components for specific tasks. Apart from original Raspberry Pi boards, many people also use alternatives like Orange Pi, Banana Pi or similar devices. I don't have them myself, but as Klipper has gained popularity, 3D printer hardware manufacturers has also started producing their own alternatives. Among them I have two boards from Bigtreetech, CB1 with the PI4B adapter and CB2. Since the Klipper host is essentially a Linux package, it can also be run on almost any laptop, mini PC, desktop or nettop. This method is a bit more complex and has some limitations, but it works, and it's used by many people. And since Android is technically some kind of Linux, it is possible to run a limited but functional version of Klipper on Android smartphones and Android TV boxes, even without rooting the device. As for the microcontroller part, Klipper can be installed on many different boards. In general, if the microcontroller on your board is supported by Klipper Firmware compiler, it can potentially work. There are a lot of supported microcontrollers, but after installing the firmware, you still need to configure the printer. Ideally, your board will already have a preset in Klipper's example configurations. There are many of them, including profiles for some popular printers, specific boards, and additional sensors and devices. If you can't find preset, try searching online. Someone might have already set up Klipper for your board. If nothing comes up, look for the board schematics and pinout, and manually configure the pins. As a last resort, you may need to examine the board physically to find how everything is connected. These last two options are useful only if your printer has a rare or proprietary board, but in that case, I'd recommend not wasting time and just getting a modern control board. The same applies to old 8-bit boards. Klipper can run on them and will technically work, but most likely they won't support modern protocols, convenient ports, and overall it will be outdated. In most cases, it's easier and more practical to buy a cheap, modern, and most importantly, popular 32-bit board. The more popular the board, the easier it will be to find answers and support. As you can see, I have several boards as examples for upcoming videos, and all of them can work with the Klipper. Another one, the most advanced, Manta M5P with CB2, is already installed in the Duender and running at full power. That's all I wanted to cover in this introduction video. In the next part, we'll start installing the Klipper Host on the different devices. The script is almost ready and I'll try to release the next parts as soon as possible. What about Duender and DIY-AMS projects? I've created Discord server, you can find the link in the channel description, and a community of very smart and friendly people united by a shared interest is gradually forming there. A few people have already built their own Duender printers and even made several improvements. I've also uploaded the beta version of Duender with MGN8 rails on the server, so you can download it and try it out. AMS a bit more complicated. I want to explain how the macros controlling it work, and to do that, I first need to cover Klipper in general. I also plan to redesign the AMS, moving the filament adapter closer to the extruder to minimize retractions during filament swaps. So this project is on hold for now, but I'm definitely not abandoning it. I also plan to upload the beta version of AMS in its current state to the Discord server. If you watched this far, thank you very much. If you'd like to support the channel financially, it would really help me. All the necessary links are in the channel description. Like, comment, subscribe. I hope you find this video useful. That's all for today. See you soon.